Now let's talk about another example about the multi-container pod, okay, or the sidecar containers pod. So multi-container pod dot YAML. Let's go with that. Okay. So when I say that we have a multi-container pods, okay. So multi-container pods, what we do is, or what we have here is, we have a pattern. Okay, we have a example of pod here. Okay, a pod name as multi-container pod. This pod is defined again. Everything kind is defined, API version, metadata, and things. You have defined the labels. Now you have to define the containers. Each container will have its own specification. Each container will have its own thing. There is a concept known as the sidecar containers. Okay, sidecar containers are what? They are the containers which run, you say that, which run in parallel, right? And they keep on doing their job. Okay, they keep on doing their job. They run in parallel to execute the task, to execute the things along with the main containers. Example, this is my Nginx container, which is a main container, okay, which is having a latest image. Now here I have introduced one more thing known as a volume mounts. Means we are actually mounting a volume to this pod, okay. We are mounting a volume. Volume of what? Of my local machine, okay, with the shared logs. Okay, this is the name of the volume, and I'm mounting it to this particular path where log engine. I have given the resources. I have given a sidecar logger. Okay, this is basically sidecar container, which is nothing again running this image, but it is doing what? It will continue to cat my logs. Okay, it will continue to check my log file. Okay, it will continue to use cat shared logs access.logs. So it will go to this volume mount point, and here it will continue to do that and sleep for 5 seconds. This is the task for this, and we have basically mounted the volume mount also on this also, and given the minimum number of resources. You see, we have given only 50 milli CPU and 64 megabytes minimum. Okay, now this is the entire configuration where we have two containers, one container known as a main container and the other container known as a sidecar container, okay, which is going to do its own task. Okay, it is going to run this pod is going to do what? It will have the two containers. Both the containers will share all the resources, will share the networks, will share the namespaces and everything. Okay, this main container is doing what? It is serving the nginx traffic here. Okay, I'm writing the logs to var log nginx, and this is the other one is reading the logs from the shared logs folder. Okay, and then we have a volume. So let's try to create this. What it says? Oh, no update pass supply file was not saved, sorry. Now if you see here, you see my multi-container demo, and both the containers are started. One, two containers are started. If you see here, you will see the container one as a nginx container. Okay, it has its own resources and things, and there is a another container known as a sidecar logger. Now, if you have to see the logs for this, okay, if you have to see the logs of this, it will ask you which container you want to log in. Do you want to log into this or you want to log into this? Which container logs you want to see? You want to see this container logs, or you want to see the other container logs, right? This container logs. So it will basically give you this pattern. Now the another important good part is, let's say we have two containers, okay? The one container is nginx hyphen container. Now if I have to see the log via the command line, I will write kubectl logs multi-container demo minus C, the container name which I want to see the logs. Okay, I want to see the logs for nginx container, let's say. Nginx container minus n Sachin hyphen ns. Now it will show me the logs for that container only. So you, with the minus C option, you can choose the container. Okay, with the minus C, you can choose the container, that which container will have the which logs, or which container logs you want to actually see here. Okay, so this is how your multi containers works. Now, you must be thinking, or you must be having the thought here that okay, when in what kind of scenarios this is important. Okay, let's say when you have to do some kind of a proxy, some kind of authentication and other things, right? When you want to run in parallel some other jobs, right? When you want to run in parallel some other jobs, or like you want to sync some files, okay? You want to sync some files. There are also the scenarios where you want example like Fluentd services there, right? Which basically collects the logs and pushes it to CloudWatch and other things. So they also run as a sidecar containers. Means they will be not directly interacting with your main containers, but parallelly they will keep on doing what? They will just help you to keep on sending the logs. Okay, they will keep on doing their own task in parallel without interrupting your main containers. This is the role of the sidecar containers, okay, which is means working in side parallelly silently. So these are very important type of containers we use. Now another important container is init container. What is that? Init containers. Okay. Init container means that the container which will be initialized at very first attempt. Okay. The container which will be initialized at very first. For example, let's see the init container example. I have this, okay, the init demo pod running with the namespace Sachin NS. It has init container which is named as init wait and busybox is the image. And it's saying initializing environments means, and it will sleep for 10 seconds and init is done. And then again, I have the main app. Okay. So now you see what will happen. I have given the wrong namespace. Now you see my both the containers are in the waiting state because my init container has not yet been initialized. If you see here, my init container, now you see my init container came up, okay, and now my second container will also come up. It runs before the main container, okay, before the one this container until your init container is not successful, okay, the main application will not start. Now you see your pod is up and running, okay, and your init container has terminated because it has completed its job, and your main container is up and running. So means init container will do its job and it will get terminated. Now another important part here is the when or where it can be applied. Init containers can be very helpful when before installing any application or things you have to apply some configurations, you have to install some dependencies, right? So consider a scenario, where we are creating the databases, okay, the for example PostgreSQL DB, right? I'm creating that now, or SQL DB. Now in that again I want to put what the uh, before my main container, before I start the main containers and things, I want to fetch my secrets. I want to fetch my configurations file, the SQL DB files, and keep it in some place, right? So there I can use that. Okay. Example, any, anywhere, where you have to ensure that any kind of the configurations has to be loaded before even my main container starts. All those places it will be very important, the init container. I'll give you the code to run this. So I have, like, let's say, the anywhere my MySQL, Redis, Kafka, all those things are running, right? So it will, until it takes time, right? Your Kafka brokers will get ready, right? Your data base will take time to get ready. So this init container you can define as a check, right? Where it will keep on checking that whether the container is ready or not, right? Whether any other dependency is needed or not, right? You can define like this that so example you can define like this, that keep on checking for MySQL service and it wait, okay, until it says the MySQL is up, right? So then don't start your main app container. So because it will take time, and as it will take time, the pod will not wait, right? Pod will do what? Pod will keep on failing. Okay, and when pod will keep on failing, you will again restart, again the same thing will happen. So that is why init containers are important, where this will be the main container which will not allow, which will only started, and it will until the other services are up and running. Okay, it will complete its jobs, it will keep and watch, okay, and it will ensure that everything is good, everything is loaded, and then it will allow the main containers to start in. Is it clear?
Yes, sir.
Yes.
So this is all about the init container. This is all about the pods, right? Where we saw the multi-container pod, we saw the init container pod, we saw the different examples of the pod and the things.